Alright, now let's crank out a few examples for these special triangles. We'll start with the 45-45 triangle. So I know it's going to be a 45-45 because I've got my angles labeled here. It's 45 and 45. So the relationship I'm going to be using is the relationship for the, surprise, surprise, 45-45 triangle. So let's take a look at what we know in this first example here. So I'm giving one leg. I know the length of one leg, it's 2. So what I have to do is use this relationship up here to figure out those other lengths. So if this is 2, so right off the bat, because it is a 45-45 triangle, I know that these two legs are going to be congruent, meaning they're the same length. So this other leg is going to be the same exact thing as this leg too. That's easy enough. So next thing I've got to figure out is the length of the hypotenuse. So let me look up here at the relationship. According to what I've got here, it's going to be the length of the legs times square root of 2. So that's exactly what I'm going to do here. Our hypotenuse is going to be our leg length, so 2, times square root of 2. So 2 square root of 2. So I've got the other two sides figured out, and I'm pretty much done with this one. Let's move on. So in this next 45-45 triangle, it's a little bit more complicated because I don't know either of the legs. What I start off knowing in this example is the hypotenuse. So I've kind of got to work backwards to figure out those other two lengths. So I'm using the same relationship up here, but I just start off knowing different information. So I start off knowing that the hypotenuse is 8. So let's use what we know about the hypotenuse to figure out those other two legs. So I know the hypotenuse is 8. But I also know that that hypotenuse is supposed to be the other leg's length times square root of 2. So let's set up an equation here and solve for what that other length needs to be. So this is my hypotenuse 8, and I know that it's going to be equal to square root of 2 times either of these leg lengths. So I'll say A, square root of 2, since I've got this leg labeled as A. So 8 equals A times square root of 2. Again, I'm just using the relationship up here for the 45-45 triangle. So let's solve for that length. So A times square root of 2, undo that, I would divide by square root of 2. So now I know that the length is 8 over square root of 2. And if I know that leg, I also know the other leg as well, because again, they are the same length in this type of special triangle. So B, my other leg, is also going to be 8 over square root of 2. Now, if we wanted to be really proper with simplifying, we would need to rationalize these denominators. So let me real quickly do that. So for whatever reason, mathematicians decided that if you've got a radical on the bottom of a denominator, then it's not considered simplified. So we do a little trick to get rid of the radical on the bottom. So we multiply by 1 in a really fancy way. So square root of 2 over square root of 2, that is just 1, so I'm not changing the number per se. But when I go to multiply this out, let's see what happens. We've got 8 times square root of 2 on top, and then on the bottom, when we multiply a radical by itself, remember that the radicals do cancel each other out. So we do end up with 8 square root of 2 over 2, which we could reduce further. 8 divided by 2 is 4, so I could say that that length is actually 4 square root of 2. So 8 over square root of 2 is what we've got for both of the legs of this triangle. That is the same thing as 4 square root of 2. Either way you want to write that, I'm okay with for now, but when it comes to a test, these do need to be fully simplified, meaning that radicals on the bottom we've got to deal with.